Broadcasting from Washington, D.C., this is Insider's Guide to Energy.
Welcome to Insider's Guide to Energy. I'm your host, Chris Sass, and with me, as always, is my co-host, Jeff McAulay. Jeff, welcome back to the program, and I'm excited about this topic. Are we going to talk about storage again?
Always excited for the energy storage conversations. And I do like getting back to the technical side. I think we spend a lot of time in finance and markets, but getting into some of the core battery chemistry and long duration, it's important.
Long duration. That's where I was wondering. So it's not just storage we're talking about. We're talking about long duration. Talk about something that I could use a dictionary to understand, because I think that means so many different things to so many people. How long is long duration? But I leave that for our guests. So why don't you bring our guest on board and let's get this kicked off?
Yeah, well, we're really happy today to have Jorg Heinemann, CEO at EnerVenue, with us. Jorg, welcome to the show. Tell us a little bit about what you do at EnerVenue.
Thank you. Terrific. Great to be here with you. At EnerVenue, we make a long duration battery, and we'll talk about what that means in a moment. Think of it, though, as the world's most durable battery technology ever invented. We use a chemistry called nickel hydrogen. It's been around for about 50 years and was deployed in the space program for about 30 years. And the best way to think of it is it's a battery that performs like the batteries we know from our daily lives. Most of those are lithium-ion, means you can charge it fast. It has a high round trip efficiency, and then it can be discharged fast or slow, depending on however you want to use it. However, unlike any other battery, it effectively lasts forever. So it's durable in terms of cycle life. It's nearly impervious to temperature. It's safe. And then it can be abused electrically, meaning overcharged, over discharged, so drained all the way to zero, etc. So it's game changing in that it's effectively a battery that doesn't wear out, really, in any sense of the word. And that makes it ideally suited for pretty much any kind of use case, for power plants, for businesses, and for homes.
It sounds great. And I really want to dig into some of those technical specifications. You highlighted a lot of them. One I didn't hear off the bat is cost. So, what are the figures of merit that you sell on, and where does this fall compared to traditional lithium ion?
I think cost is probably the number one thing that matters in a battery long term. And when we get to talking about what's the definition of a long duration battery, my view is it fundamentally comes down to economics. We have a battery, our cost is effectively at parity with lithium ion, and most importantly, where that's going. And I'm referring to all flavors, so lithium iron phosphate, et cetera. So we've got a technology that can keep pace on cost, yet at the same time give customers additional value that they are willing to pay a premium for. So the things I described, the longevity, the durability, even the safety, those are things that you can price into, and many of them you can calculate on a spreadsheet, and we can effectively price to value and give the customer additional value, and even though they're paying more for the battery, and they still come out ahead relative to using other forms of technology like lithium ion.
Mm-hmm. And what applications are we talking about? I think when you bring up long duration, I'm thinking of grid tied, front of the meter, large scale, multi-megawatt installations. Is that the right place to think about this?
Yeah, it's all of that, and then eventually it scales down for commercial and for residential as well. Our battery has a unique combination of fire safety and no maintenance, and that allows us to create a new category we call building integrated energy storage. So think having our batteries hanging next to the drainage pipes, say underneath your floor in a crawl space of a home or up in an attic, et cetera. That's down the road for us, think 5+ years out, et cetera. As we're scaling up, we're focused mostly on grid scale, typically solar plus storage, and then use cases where a customer would want to do more than one charge discharge cycle a day. So think solar plus storage, maybe an additional cycle for faster for EV charging, or a morning bump like a lot of markets around the world have, where they have an evening spike they need to smooth as well as a morning spike they need to smooth out.
You mentioned in your answer, or make it clear, you keep saying we have this battery, and you talked about the powers of this battery. Battery space or storage is a crowded space these days. So help us understand a little bit of the landscape, because you're saying you're long duration. Not quite covered what that is. It sounds like your grid scale from the question Jeff asked. That's your near term, with longer term going smaller. What does the battery space look like, and what specifically is the problem that you set out to solve?
Yeah, well, let's start with the definition of long duration, and I think that stems from if you look at the energy landscape right now. There's two ways to view it. There's the folks that come from the legacy energy industry, and we're all accustomed to our electric power grid working effectively the same way as it has for the last 100 years. Central station generation, transmitting large blocks of dispatchable power one way across a distribution network, a high-speed network, and then consumed at a point of variable load, all at super inexpensive prices on a relative basis. So if you come from that industry, you're used to power coming in the form of big blocks. So I'm going to bring 1,000 megawatts up. I'm going to keep it steady for 8 hours. I'm going to drop it back down to another level, et cetera. And that most of the energy world thinks that way. There's a different part of it that comes at it the opposite way. That's more, think kind of microgrid-ish. I'm going to take solar, I'm going to put it in a battery, I'm going to consume it however I want to. And so you get a lot of folks who are saying, well, gee, I need a battery that will last 4 hours, now 6 hours, now 10 hours, maybe 24, maybe 100 hours at peak capacity. And at EnerVenue, the way we see it is a little bit different, that really what the market needs, depending on whether you're coming from the legacy energy world or you're skipping the landlines, you're moving into the full distributed generation microgrid world. What I really want is a battery that works like my cell phone. I want to be able to charge it fast, say within 1 to 2, maybe 3 hours, whenever there's cheap solar power available, or just simply excess electrons on the grid. And then I want to be able to dispatch it based on my use case, either fast or slow. So the notion of, well, yeah, I want both. I want a battery that'll last 10 plus hours, 24 hours, maybe 3 days, but also be able to drop it really quickly into an electric vehicle in, say, 15 minutes if I need to. And that flexible dispatchability is really hard to do in the battery world. Lithium-ion can do it. We can do it. We can actually do it perhaps even better, because we have no limitations in terms of the long-term durability of the battery. The customer can do that 30,000 times if they want to. So I think that'd be 3 times a day for 30 years. It's basically a infinite life battery.
Mm-hmm. That's great. And it would be wonderful to get into some of those specs. So 30,000 cycles with less than 20% capacity fade or something. Is that how you define cycle life?
Pretty much, yeah. So it's almost infinite. So think the design life is 30,000. We warranty 20,000 cycles. So think at the end of 30,000 cycles, I would still have over 80% of my original capacity in practical terms. And that's despite how I use it. So we let the customer do whatever they want in terms of charge rate. We give them a really broad range. Our current product that we're selling today is between 2 and 12 hours. So I can do a 2-hour charge to a 12-hour charge. The chemistry supports anything from 10 minutes to 24 hours plus. But you have to optimize a bit based on current carrying capacity and that sort of thing. So it's
can you use the
flexible.
And sorry, the technical term are often C rate, which
Yeah.
is, so you're saying you could do a 10-minute full discharge?
Yeah. So think 6C all the way to C over 24. Again, our current product, we've optimized for C over 2 to C over 12 to a 2-hour to 12-hour charge. But the chemistry is such that you can go even higher.
Wow.
In our R&D center, we do a lot of high charge rate stuff because it stresses the battery more. It's a good way to get more cycles in, and you can make sure the performance is what you expect it to be, especially over at high temperatures or at very low temperatures.
And so when you're talking about 20,000 cycles warranty, is that including limitations on the C rate?
Uh, Effectively, no. So we have a spec sheet for the battery, and the spec sheet is, in this case, it's 2 to 12 hours, and then we have a temperature range. That temperature, I believe, is -10 to +45 Celsius. So again, that's we tighten the bounds for the customer, and we say do whatever you want with it as long as you're within that range.
Got it.
So it ends up being the shortest warranty agreement by far in the industry.
So you're going to be thermal limited before your C rate limited, probably.
To some extent, yes. So we do a lot of testing at 60 degrees Celsius. And then the performance, though, even at say 50 and 55, we go from a round trip efficiency that say at room temperature is about 90% at a 4-hour charge rate of C over 4. That drops to about 81, 82% at 55 degrees Celsius. And then the same thing, it extends well below freezing. And all of this is without air conditioning, without heating, et cetera. So the natural, they call it kind of the umbrella chart of our battery, is extraordinarily broad.
Now, when someone's looking for storage, are they having a conversation just like Jeff's having with you right now? Are they going to that detail, or are they looking at this higher level today?
They're usually, for grid scale and then large commercial customers, they're very sophisticated. They're modeling everything. They're looking at all of the components that factor into the levelized cost of energy coming out of the plant or the project that they're building. So they're looking at the upfront capital cost. How much does it cost to buy the battery? How much does it cost to install it? What's my cost of capital, the debt and the equity I need to finance the project? And then they're also factoring in the maintenance cost. So in battery terms, think about it. Well, I have to plan for this thing to wear out. And that's one of the huge economic levers that we have at EnerVenue is the thing doesn't wear out. So there's no augmentation cost. There's very little routine maintenance. Actually, there's perhaps no routine maintenance required on our battery except checking the thing every once in a while. It was this chemistry was designed to be sent into outer space to be on a satellite for 30 years or the International Space Station. So the notion of having to go, periodically replace and augment battery packs it's not part of the equation, which is a massive economic advantage.
I guess one of the layman concerns that I hear when I talk to folks about batteries is supply chain and the materials going into the batteries. People say we're going to electrify the world. We need a lot of batteries. You need a lot of different materials to make these batteries. What are the batteries we're talking about, and how do they fit into that equation?
Yeah. So what at EnerVenue we use nickel hydrogen. We use nickel in both the anode and the cathode. That is the core element of what I call the energy couple. And every battery has an energy couple. Think of that as that. Those are the amount, or think kilograms worth of elements I need to store the electrons to form the battery. So in our case, that happens to be about 2 kilograms of nickel per kilowatt hour of energy storage. So if you do that math, you say, okay, take the street price, commodity price of nickel, multiply by 2, and you get your cost of an energy couple. And then that can be used comparatively to other chemistries. It turns out we're right in line with lithium-ion, the different flavors of it and where that's going. Nickel happens to be less constrained than other battery materials. It's the 5th most common element on Earth, the 22nd most common in the Earth's crust. It's available in nearly every geography. It looks from a commodity standpoint much like polysilicon does in solar. It's a function of mining capacity as opposed to a function of fundamental scarcity. That's very different than, for example, vanadium, which is used in certain types of flow batteries, and then very different from catalysts. So our battery uses a catalytic reaction, and the earlier version of this battery before EnerVenue changed it relied on platinum, which is a rare earth metal, extremely expensive. Our founder, Professor Yi Shui at Stanford, his team found a way to eliminate platinum from the battery, replace it with a very low cost catalyst. And that's what put us on the map.
That's exactly what I was going to ask, because it seems uh, you'll understand too good to be true. And so it's a chemistry that's been out there, it's been tested in space. Why haven't we heard of this before? And so it sounds like that's the reason, that there used to be a precious metal catalyst in there, which is one of the things that's plagued PEM fuel cells, for example. And
That's right.
so once you can get rid of the platinum, that was the limiting factor to more commercial application. And so now, what replaced that is the catalyst, now that you don't have the platinum?
Yeah, in fact, so I'll build on that. The cost disadvantage was so massive that back 15 years ago, when a lot of us got into renewables, I got into the solar business around that time. Many of my colleagues got into batteries. The industry drove right past this technology because the calculated cost, best we can tell, was somewhere between $15,000 and $20,000 per kilowatt hour. 85% of that was driven by platinum. So it's like a forget about it. There's no way we can do this. Platinum costs about $30,000 a kilogram. The catalyst we use, which is an alloy of earth abundant stuff, costs about $20, 20, per kilogram. So we took what was by far the most expensive part of the BOM and reduced it to effectively zero. And then we redesigned the form factor. We made it easier for large scale manufacturing and use on Earth as opposed to sending up into satellites and that kind of stuff. So we get savings there too. But it's really that platinum replacement that allows us to be cost competitive.
Can you tell us about the manufacturing process and where you are in terms of scale? We hear about gigafactory this or that, and then there's a lot of promising chemistries that might be in scientific papers, but they're still at coin cell level. Where are you guys in terms of annual production volume?
Yeah, so one of the things I learned in moving from the high tech world into the battery space is that batteries move really, really slowly. So anything that sounds like a new technology in batteries has probably been around for at least a decade. And therefore my hypothesis is if it didn't work 10 years ago, it's unlikely to suddenly work overnight right now. So our battery technology has worked and been proven in aerospace applications for 3 decades. It's got a super robust track record. We made a material substitution. We've demonstrated that works. Much to my pleasant surprise, it actually outperforms platinum. So our catalyst for this use case at the current densities we operate at is actually better in terms of round trip performance, energy capacity, degradation, all the characteristics you look at, it's better. Our manufacturing process is super simple. We rely on what's called a large format cell. So that means kind of bigger materials, thicker materials, which means fewer of them than lithium-ion and than many other technologies. Our smallest increment, if you will, is we call it an ESV, an energy storage vessel. It's about 6 feet long, 6 inches in diameter. It's a tube and has an energy storage capacity of about 3 kilowatt hours. It's made by creating electrodes. We do that through an electroplating process, which has been around for 5 or 6 decades, used in many other industries. And then we stack these electrodes and the stack separators. And the precision is such that humans can do it as opposed to needing robots, but it works a lot faster with robots. And then we weld it together and we seal up the vessel and it's done. There's a little bit of testing and things, of course, but it's a much simpler process. It's very safe. It relies on standard robotic equipment, like those 6-axis robots you might see in an automotive factory or white goods manufacturing, and standard laser welding equipment, again, robotic. So we're able to borrow from adjacent industries and avoid having to have I'll call it a specialty line built just for us with high precision equipment that deals with super thin materials and so forth.
Awesome. I love the visual created in my mind as you described that. I always find manufacturing and how we get things at scale or economies of scale interesting, of how you keep engineer the costs out of things. Which brings me back to early in my career, I was a technology and telecom and other fields, and we certainly engineered our products down and we designed them down. You mentioned in the beginning of your answer, kind of you alluded to a technology background. how much of this renewable energy in battery tech and other tech that we're doing comes from people that come from a technology background from other tech fields?
Yeah, interesting question. I think some of it does. So I began my career at Accenture. I was a partner in the high tech practice for about 20 years doing large scale business process change and outsourcing stuff. So think kind of build, fix, change for high tech companies. And in the late 2000s, I decided I wanted to make a change, do something that would have a bigger impact on the planet. So I started a sustainability consulting practice within my industry group, and that ultimately, you could argue, I guess I wasn't very good at that because my first run out of the gate, I got hired by SunPower with the CEO there. I was trying to sell him consulting work, and he sold me on a job instead. So I went into the solar business for 8 years. And what I found is, I think candidly, there's some big lessons in high tech versus energy. The biggest one is high tech tends to operate on first principles and doesn't rely very much on incentives. I got into the solar business, and it seemed like the game was, where do you chase the incentives around the world? I'm going to go sell my product at the place where I can capture the highest level of government incentives for the longest period of time. Um, and in the high tech world, you just don't think that way. You think, okay, how do I make the best product, get it out there, and have it meet the customer's needs on a first principles basis, and then move on. Ironically, that's where the energy industry is moving to. So solar today, it used to be, back in 2008, 2009, it only worked with incentives. That was true. It took about 5 years beyond that, where it started to work on an economic basis in more places. Today, I think we can all agree solar is by far the lowest cost form of power generation out there on any basis without incentives. Now, of course, the industry would like to keep incentives as long as we possibly can. It makes things more profitable, but that's where you go no matter what. And as I look at batteries, the same thing applies. Well, we need a battery. I'm a big believer in the business case for a battery company. Boy, it better work without incentives. Now, it so happens it works better with the Inflation Reduction Act that we have in the US and these other incentives around the world. But boy, this thing better hold water, no matter what, even after these incentives fade off into the distance. And EnerVenue, of course, I'm convinced that's the case for us, or I wouldn't be here.
Yeah, you certainly mentioned that. It sounds like you also manufacture in the U.S., so that should help with domestic content and part of those incentives as well.
We do, yeah. We have a pilot manufacturing line here in Fremont, California, co-located with our research and development in the same building. And then we have a factory in Kentucky, just outside of Louisville, that will be scaling up over the next 2 years. And that'll have at peak capacity, it'll reach about 20 gigawatt hours per year annual production.
Mm-hmm. And when you think about markets, do you think about energy storage as a market in itself, or do you think about energy storage as a product that serves other market? You mentioned satellite, aviation, grid scale storage. Do you think of those as the markets you're entering, or more as energy storage?
So at EnerVenue, we think only about stationary energy storage, grid scale, commercial, industrial, residential. That's it. And that's based on the limitations of our product. You ask about, hey, what's the catch? Well, one was cost, going from platinum to our catalyst. The other is size and weight. We are larger and heavier than lithium-ion and always will be. There's a physics reason I can get into if you're interested. We are lighter and smaller than everything else in kind of any other non-lithium battery. But if it moves, go with something else. If it's stationary, the ground is holding it up, hey, we're probably the right play for it. We're the ideal all-purpose battery for power plants, businesses, and homes.
Got it. That makes total sense. And it seems like that, back to the point on background, that consulting rigor, discipline of what are the attributes of what you need to succeed in a certain market is leading you to focus on what are the natural attributes rather than trying to chase too many things.
Yeah, absolutely. And one of the things about batteries I've learned in the energy storage industry is, A, it's interesting to almost everybody. B, there's so many use cases out there. It requires a significant amount of focus. I can't tell you how many times folks have said, "Oh, can we put this on a boat?" Well, yeah, maybe. Could we put it in? What about a train? Yeah, but when you really, or how about a forward operating base in the military? We're going to drop in kind of a temporary, uh, a temporary base for a while that needs short portable energy storage coupled with solar. All those things might work theoretically, but if you're going to move it, eventually that cost of transportation, the weight's going to be a factor, and it's going to make it unlikely that our technology is the best suited. So we'll let the others play in those areas, and we'll focus on power plants, businesses, and homes.
Well, you've got a very well defined space where your batteries go, what problem they solve. So that's always something important. As I look at the demand curve going forward, so if I look at, let's say, 2035, 2050, and the projections where batteries are, you mentioned you're building a plant in Kentucky. Is storage at the point where if you could build it, would you sell capacity? Are we at that stage of the market? Because everything you read about is everything's getting electrified. The renewables need some sort of storage to be meaningful. Um, what's the demand currently with interest rates and the market today for new projects and infrastructure? Yes, we have the IRA, so there's money going to certain projects, but is the demand a steep linear slope, and could you sell as much as you could produce?
It's a steep linear slope, and the reality is it's probably even steeper, even more linear, even longer and bigger than we think it is today. So at EnerVenue, we're sold out effectively for the next 6 years. We're in heavy allocation mode while we scale up. I've been watching the demand charts that the analysts produce. Very sharp people are, year on year, looking at the projected market growth just for the stationary element of the market. And I look at that, and it's massive. I mean, there's kind of no way, any way you slice it, it's far more than we could hope to fulfill, even if we put factories the size of the one we're doing in Kentucky, multiple of those in every geographies. We still don't come close to reaching what's needed to meet that demand. And then when I look at kind of the data behind those analyst projections, um, I think they're still low. As big as they are, it's still low when you factor things like, all right, let's take a look at the annual solar panel production that's happening. And then if we make a simple assumption like, well, what if we had to attach batteries to, say, 10 or 20% of that output, which is a very logical thing you could argue that we would need. Say you want 4 hours of energy storage attached to every megawatt of solar panel out there, you end up with even bigger numbers of market size. So the obstacle isn't market, it's how quickly can we scale this? And then it's also one of those things where I think we're going to find as we have more energy storage at lower and lower cost, we now have more things we can do with it. So you get a snowball effect. The things we think we couldn't do with solar plus storage, I think we're going to look back later and say, yeah, actually we could, especially when we marry sophisticated energy, I think high-tech energy management capabilities with that.
Jorg, I want to come back to the energy management and maybe the software piece, but just on the ramp, what is the limiting factor? Is it supply chain and access to cost-effective nickel? Is it permitting for the next factory? What's the limiting factor in the growth?
For us, it's basically equipment lead times. So although our manufacturing process does rely on mature technologies, it still takes a while to dial in the line. You have to buy the equipment, you have to get the robots, those kinds of things. And then because it's physical as opposed to software, hardware is hard. That expression you may have heard. it's true. There's lead times associated with making a physical thing that are very difficult to get around, unlike, say, a software product.
And on the software side, is there a third party integrator who does the controls, or is the chemistry unique enough that you're packaging with your own battery management and or application control systems?
A bit about both. So our battery works differently from other batteries. So we have our own BMS, our battery management system, which is the thing that basically controls the mechanics of how it charges and how it discharges and how it holds steady. It's designed, though, to integrate with the customer's EMS, energy management system. And those interfaces are predefined, and we basically speak the same languages. the many, many EMSs that are out there.
That's great. What are you most excited about? It seems like, gosh, you're sold out for 6 years. Only limiting factor is how fast you can build this stuff. It seems like you've got some great um, specs on the spec sheet, which I would be excited to keep going through. But it seems like we covered a lot of those. What are you most excited about in the next year?
Well, I'm really excited. So I've got an R&D team, and I'm used to working with R&D that is optimistic, but then kind of falls short of expectations. And what we've seen here since the beginning in EnerVenue, and from my very first day meeting with Yi Shui, the founder, and then Majid Keshavar, our CTO, they showed me a spec sheet, what they thought they could do. And of course, I discounted it and said, well, okay, it's probably only 80% of that. And sure enough, 6 months later, we had exceeded but my threshold, their threshold, and we were actually even well above the legacy specs at that point. And that pattern has persisted since then. So just now, we made the decision to leapfrog from Gen 2 to what we call Generation 4 of our energy storage vessels. That's what we'll be going to large scale production with. And the reason for that is that the R&D team is about 2 years ahead of the engineering improvements that they've made, which again, I'm still adjusting to that. I kind of wish they would tell me a little further in advance so I could I could let the investors know ahead of time. But it's definitely a very good place to be.
So, other than managing internal or investor expectations, one of the things battery comes up is China comes up a lot when I speak battery. So, you talked about an onshore battery production plant in Kentucky. You've talked about a development team. You talked about being in California. You've given us a bunch of onshore technology. So, how does this play and compete with China? What are the lessons learned, and what are you going to do well, or where's China going to win or lose?
Yeah, I think we're going to look back. I think China over the last 20 years has figured out the global playbook for large scale, low cost, high quality. So if you enter the workforce like I did in the late 1980s, you grew up with what we know as the Toyota way. It's basically the Japanese way of doing manufacturing. That's the playbook that spread across the world. And I'd say up until 10 years ago, if you were anybody doing any kind of manufacturing and had a supply chain, you were trying to do things in the Toyota way, that set of quality principles and management structure and so forth. If I were a business school professor right now, I'd be writing a book called The China Way. I think China has dialed that in, and the rest of the world is trying to figure out how to do that. So the ability, and we saw this in solar, for example. China owns 80% of the solar panel production. They do it super low cost, super high quality. They can scale faster than anyone. We're seeing that in batteries with lithium-ion batteries, many other industries. So it's up to the rest of the world to figure out the playbook and then go adapt that. Some of that is driven by tariffs, as we're seeing in the U.S. Some is driven by incentives. How can we onshore, basically take Chinese companies, have them build factories here so that we can learn that playbook? Or how do we do our best to copy that? And that's the challenge. Certainly, a challenge anywhere in the battery industry, but more broadly in the energy sector, and candidly, pretty much every other sector that manufactures something at scale.
That's really, really fascinating, and I love the comparison there. When you think about your personal journey, you've had the experience in the high tech sector on a consulting basis. You've been behind the scenes at SunPower deploying real energy assets at scale. When you think about applying some of the lessons you're seeing from China to the business today, what in your personal and professional journey do you think most prepared you for that next step?
Um, I think there's two things that I take with me from my consulting background. So one is it, it's a mindset of how do you constantly improve and take cost out, and there's a structured way of doing that. And the Toyota way would be the best example, kind of in the manufacturing word, if you had to boil it down into two words, but kind of the constant pressure to build, fix, change, improve. That's one. Um, the second one I think is more unique to consulting and the way the people side of it works. In the consulting world, there's a constant pressure to serve the client well, even when you're charging them crazy high rates. And that means you have to build a team super fast. And that team has to be really, really good and justify that what would seem like an exorbitant billing rate to the customer. And so there's an inherent mandate to assemble my team quickly, think recruiting, hiring, and make sure they're performing well. And if they're not, take action really fast. So it's this bias for building a really good team really fast and making that the number one priority. And the people in the consulting world that are unable to do that, they don't last very long. And I think in the rest of industry, when I left, I'll call it Accenture in the consulting world and entered a line responsibility, I found the people side of it moved much more slowly. Most people are biased as, well, I'm going to do everything else, and then I'm going to write a job description and work my way through the hiring process. It becomes kind of an afterthought as opposed to the first thing. And I was forced to put that first for 20 years, and it's stuck with me ever since.
Thinking about our audience listening to this, somebody who's interested and intrigued, maybe doesn't understand all of the technical jargon yet, would you advise them to go out and really go deep and understand the technical specs of energy storage? Or if somebody's earlier in their career, that they should go learn how to be a consultant and understand the dynamics of industry? Obviously, it's not either or, but if you think back about somebody who's just getting started in their career, what do you think's more important as a foundation?
Oh, if I were to give career advice, I'd say I'd set aside industry and say, go find something where you can learn, you're working with good people, and you find it fun and inspiring, and you're able to make a difference. And in my case, I was never, some people think years and years ahead. I never thought more than 2 years ahead in my career. The same thing is true for me right now. And as long as I like what I'm doing, I feel like I'm making a difference, I like the team I'm with, and I'm learning, I'll stick with it. And if not, I'll look for a change.
Jorg, what a fantastic message to end on. Really love that. It's inspiring, not only the products you're building, but the journey you've been on. We're very optimistic to hear more about EnerVenue in the coming years as you ramp up production. Thank you so much for taking the time today.
Thank you, Jeff and Chris. Really enjoyed the conversation.
What a fun interview. We have a definition of long-term storage. We now have some other perspective on batteries. If you're interested in battery tech, please go back to our archives. We have a number of battery episodes. This episode shows you some emerging trends. Follow us on LinkedIn, subscribe to us on YouTube, and we'll see you again next time on the Insider's Guide to Energy. Bye-bye for now.